In this video, we will discuss classification of functions based on how the function assigns elements in its domain to elements in its range. Remember that a function is a rule that assigns or maps distinct elements or input from its domain to distinct elements or image or output in its range. So here, we have a real valid function of a real variable that is defined by y equals to f of x. I have itemized 7 of these classifications based on how the function assigns elements from its domain to elements in its range. And we are going to illustrate this classification of functions using geometric interpretation or diagram. The first we have is the constant function. Here, the function assigns every element in its domain to a single value or image in its range. Here, the function assigns S1 to C, S2 to C, S3 to C, until it assigns Sn to the same C. It assigns every element in its domain to a single value in its range. And the rule y equals f of s is denoted by C, the single value that this function maps all the elements in its domain to. The second classification is the identity function. Here, the function f associates or assigns every element in its domain onto itself. The function f assigns S1 to S1, S2 to S2, S3 to S3, S4 to S4. It continues in that order until it assigns Sn to Xn. It assigns every element in its domain onto itself. The rule y equals to f of x is the same thing or denoted by x. This function is usually denoted as the identity function of x. But if it happens that the function assigns distinct or different elements from its domain to distinct or different elements in its range, then that kind of function is what refers to as one-to-one function or an injective function or simply an injection. Here, the function f assigns S1 to Y1, S2 to Y2, S3 to Y3 until it continues that order until it assigns Sn to Yn. That is to say that a function is one-to-one if and only if for two distinct elements s1, s2 in the domain of the function, f of x1 being the same thing as f of s2 implies and is implied by that s1 is the same thing as s2. Or for the two distinct elements s1, s2, f of s1 not be the same thing as f of s2. It implies and is implied by that s1 is not the same thing as s2. But if it happens that the function assigns at least two distinct or different elements from its domain to a unique value or single value in its range, then that kind of function is what refers to as many-to-one function. Here, the function f assigns s1 to y1, it assigns s2 to y2, but it also assigns s3 to y2 until it associates other elements in its domain to other elements in the range. That is to say that if I have at least one single element y star that happens to be in the range of the function, I have that for some I not being the same thing as j, f of si is the same thing as f of sj is the same thing as y star, then that kind of function is what referred to as many-to-one function. An example of this kind of function are the Heaviside function, the signum function, the absolute value function or the modulus function, the polynomial function of degree n, where n happens to be even values. Now, if it happens that for all the elements or images in the range of the function, I can only have an element in the domain of the function that is mapped to it. That is to say that for all the elements or for all y in y, which happens to be the range of the function, I can always have at least an x in the domain of the function that is assigned to that particular value. Then that kind of that kind of function is what refers to as onto function or a surjective function or simply a surjection. Remember that we are dealing with real valid function of real variables, and so this becomes the codomain of our function if it happens that the range of the function is the same thing as the codomain of the function, then that kind of function is what we refer to as onto function. But when it happens that the range of the function is less than the codomain of the function, that is, the range of the function is a proper subset of the codomain of the function, which happens to be, in this case, the set of all real numbers, then that kind of function is what refers to as into function. And into function, that is, the range of the function is less than or is a proper subset of the set of all real numbers, then the function becomes an into function. However, sometimes a function can satisfy the condition of being one-to-one. It can also satisfy the condition of being an onto function, and we call that kind of function one-to-one and onto function, or a bijective function, or simply a bijection. Remember that the function will be one-to-one if it satisfies this condition, that is that for two different values are picked in the domain s1, s2, f of s1 being the same thing as f of s2, it implies and is implied by that s1 will be the same thing as s2, and the function will be an onto function if it happens that all the elements in the range of the function happens to be an image of at least an element in the domain of the function. That is to say, it will be an onto function if the range of the function coincides or happens to be the same as the codomain of the function. Another interesting thing to note here is that when a function is both one-to-one and onto, then the inverse of the function will exist. In other words, for the inverse of a function to exist, the function have to be one-to-one and onto. However, the function of an inverse may not necessarily be a function. In other words, if a function has an inverse, it is not always true that the inverse of the said function will also be a function. For example, if I have a many-to-one function and the inverse exists, then the inverse will then be a one-to-many function, and a one-to-many relation is not a function. That is to say that the inverse of this kind of function will not be a function. These are the classification of functions based on how a function assigns elements in its domain to distinct elements in its range.